All right, we can come back to that if anyone needs it after today's lesson. And today we are going to be solving systems by a technique that's called elimination. And once you get a little bit of experience with this elimination technique, you'll probably use it instead of the substitution. Doesn't matter how you solve the system, but I think elimination might be the simplest. So let's say that you've got a system that's got a 4x plus 2y equal to 9 and a negative 4x plus 3y equal to 16. Okay, what you're allowed to do when you're solving these systems is at any time you can combine the systems, meaning you can add them together. So when you look at these systems from the beginning, you're always looking at them going, okay, I want to get rid of a variable. And yesterday we would solve for a variable and then substitute. But if we're looking at these two equations and our goal is to get rid of one of the variables so we can solve for the other one, and we know that we can add or combine the two equations, we've got a positive 4x and a negative 4x. Okay? So if we just combine these equations, basically add them together, the 4x minus 4x cancels and it disappears. The 2y plus 3y gives us a 5y that's equal to 9 plus 16, which is 25. If you divide both sides by 5, we get a y that's equal to 5. So we've now solved for one of the variables. Once we have solved for one of the variables, the next step is the same as yesterday, and that's to substitute. So I'm going to go back to the top equation, and where there's a y, I'm going to replace it with a 5. So I got 4x plus 2 times 5 is equal to 9. I get 4x plus 10, that's equal to 9. If I subtract 10 from each side, I get 4x that's equal to negative 1, and then divide both sides by 4. So our x is equal to negative 1/4. So our solution for this system is negative 1/4, 5. So whenever you look at the two equations and they have opposite numbers in front of the variables, just add the equations together. When you do that, it will eliminate a variable. Solve for that variable and then substitute. After that, you're finished. Now, that's as easy as elimination gets. All right? So the other type of problems you'll see today will look like 3x plus 7y equals 15. And 5x plus 2y is equal to negative 4. All right, so this takes a little bit of thought. if we add the equations together right now, 3x plus 5x gives us an 8x. 7y plus 2y is 9y. And 15 minus 4 is 11. So nothing would get eliminated. Okay? Now, what you're allowed to do is multiply either equation or both equations by a number so that you'll have opposites in front of a variable. So here's what I mean by that. If I decide I want to eliminate the x's, all right, 3 and 5 both go into 15. Agreed? So if 3 and 5 both go into 15, I'm going to try to get a 15 in front of the x and a negative 15 in front of the other x. And I can do that by multiplication. If I multiply the whole top equation by 5, watch what happens. 3x times 5 is 15x. 7y times 5 is 35y. And 15 times 5 is 75. These equations are equivalent to each other. All I did was multiply everything in the equation on the left by 5, and it gives me the equation on the right. Now, since I decided to eliminate the x's, and I've got a 15 in front of this x, I want to get a negative 15 in front of the other x. So now I'm going to multiply the bottom equation by negative 3. So 5x times negative 3 is negative 15x. 2y times negative 3 is negative 6y. And negative 4 times negative 3 is positive 12. So the 15x's cancel each other out now. Now I'm going to combine the equations. The 15x's cancel. 35y minus 6y is 29y. And it's equal to 75 plus 12, which is 87. If I divide both sides by 29, I get a y that's equal to 3. I've got my y. I can go back to either equation now and substitute the 3 for the y. So I'm going to go back to the top equation and take 3x plus 7 times 3 equals 15. So my 3x plus 21 equals 15. I can subtract 21 from each side. My 3x is equal to negative 6. And then divide both sides by 3. So we get an x value equal to negative 2. So our solution for this system is going to be negative 2, 3. And solution for the system means I can put negative 2 in for x and 3 in for y into both equations, and it will solve those equations. I could also graph both of the equations, and they will intersect at the point negative 2, 3. If I graph the first equation, graph the second equation, they will intersect at negative 2, 3. All right, so let's do one more of those equations where we have to kind of manipulate a little bit. Let's solve for 2x plus 7y equals 4. And 3x plus 5y is equal to negative 5. All right, so if we look at the equations, if we combine them now, we're not going to eliminate a variable, right? And I'm looking at, I got a 7 and a 5 I could work with, or a 2 and a 3. 2 and 3 both go into 6, right? And 6 will be easier to deal with than the 7 and the 5, which would be 35. So I'm going to try to get a 6 in front of this top x. So I'm going to multiply the top equation by 3. And I get 6x plus 21y is equal to 12. In the bottom equation, I want a negative 6 in front of the x. So I'm going to multiply the bottom equation by negative 2. So I get negative 6x minus 10y equals 10. All right, so my 6x minus 6x is going to cancel. The x's are gone. 21y minus 10y is 11y. And 12 plus 10 is 22. Divide both sides by 11. We get a y that's equal to 2. Go back to either equation and substitute the 2 for the y. I'm going to use the top equation again. It doesn't have any negatives in it. So I get 2x plus 7 times 2, that's equal to 4, which gives me 2x plus 14, that's equal to 4. Subtract 14 from each side. So I get a 2x equal to negative 10. And then divide both sides by 2. So our x is equal to negative 5. So our solution is negative 5, 2. Anybody have any questions? All right, then your practice for today is going to be on page 146. 30 through 33.